So we're going to start solving problems with more than one triangle. Remember, in order to solve a right-angled triangle, you need 3 pieces of information, and one of those pieces of information has to be a side. When those 2 triangles are put together, it says calculate the length of xy. I'm just going to put an x there because that's what I want to find. I want to solve for x. But if I look at this triangle, xwy, and I'll draw it off to the side here in red, xwy, and I know that this is 22 degrees, and I know that it's a right-angled triangle, but that's the only thing I know about that triangle. I only have 2 pieces of information. I have no sides. This cannot be solved the way it is right now. We won't be able to solve for this x just using that triangle. However, if I look at the triangle WYZ, I'll draw it here in blue. WYZ, I know this is 20 degrees, I know this is a 90 degree, and I know this hypotenuse is 8.4. Can you see in that triangle that you have 3 pieces of information and one of them is a side? So we could solve for that whole entire triangle if we wanted to. That's what we were doing in this last unit. Solving a whole entire triangle, you could find all the angles and all the sides. However, this question, we just want to find x. It didn't say solve for everything. You could if you wanted to, but you just have to find x. So as far as a strategy goes, what piece of information from the blue triangle is going to help me with my red triangle? This length right there, right? Because this is the one that they share. Both triangles share that green line. That's right here from W to Y. If I want to find that, sure, we can use little z for that. If I want to find that, what ratio would I use? Sine. Sine of 20 degrees. Because SOHCAHTOA, all of our definitions, we want to find the opposite side, and we know the hypotenuse. So we would have z over 8.4. How would I get z by itself, algebraically? Times both sides by 8.4, because that's the opposite of dividing by 8.4. And we get 8.4 sine of 20 equals z. Type that into our calculator. .4 sine of 20. And we get 2.87. That tells us this is 2.87. That tells us this line right here, this green line, is 2.87. That is going to help us. Now we have in our red triangle up here, we know what that length is. Now we got 22 degrees. We have enough information in the red triangle to solve the whole thing, but we just need to find x. Sine, cos, or tan. Cos. Because what we want to find, the x, is the hypotenuse, right? So because we want to find the hypotenuse, you know it's going to be sine or cosine. And we know on the 22, this is the adjacent side to the 22. So then we would use cos. So we'd set it up. Cos of 22. The adjacent side is 2.87. And of course, I'm going to keep all the decimal places right till the end. Divided by x. Now with our fraction, note that x on the bottom, you would multiply both sides by x, And then you're going to divide both sides by cos 22. And we saw last class, right, how that just switches those two. Because if I multiplied both sides by x, that would move the x. That would move the x, and cancel out here and move the x up over there. And then if I divided both sides by cos 22, that would move the cos 22 to the bottom of the fraction. Go to our calculator. Since we have 2.87 stored in there, we can just hit divide. It'll automatically take that answer and divide it by cos 22. 3.09. Rounded to the nearest tenth would be 3.1. Our units are centimeters. That's our final answer, so we would circle it. Did it ask for the nearest tenth? Yes.